Okay. Thank you, Cruz. Cruz.
Keep having vision.
Okay, today we're going to look at Z scores. So yesterday we talked about the bell curve, right? Normal distribution, and we did the percentages and everything like that. You should have picked up one of the sheets that was at the front here. That looks like this. It has a table on it. Yeah. Okay. So you'll notice that it has the little bell curve on it, the normal curve. And what these are, and we're going to look at this, is values of what the area is. So last day, we looked at just the main structure of it, right? And we divided it into standard deviations. 1 standard deviation out, 2 standard deviations out, 3 standard deviations. But what happens, so last day it was, the standard deviation was 10 kilometers, right? So, but what happens if I was driving 107 kilometers an hour, right? Then what percentage would that represent? It's in the middle, right? It's somewhere in here. So it doesn't, those values are only for 1 standard deviation. So 107 doesn't represent 1 standard deviation. It's the mean plus a little bit. It's not quite a full standard deviation. So what this chart will do is it will give us the area of those spaces in between. All right? So how do I calculate those? I calculate them with a Z-score. Okay? So the formula for a Z-score looks like this. Z is equal to X minus the mean divided by standard deviation. Okay? So X would represent my 107 kilometers an hour, right? And that sort of thing. Z could be, right? Z could be just 1, 2, 3, right? It could come out to an even number, but it also could come out to be a decimal. Meaning when it comes out to be a decimal, it's not quite as far as 1 standard deviation away, 2 standard deviations, 3 standard deviations, right? So for example, yesterday, so I'm going to use the example from yesterday, right? This score right here, we had, so example from the last day, example, we had the cars, the speeds, right? So I can show you, you can use this formula to find even those. So we had our mean at 105 kilometers an hour. Standard deviation was 10 kilometers an hour. Okay? Now, using that little picture, we plotted out what was 1 standard deviation, what was 2 standard deviations, that sort of thing. All right? So I'm going to show you that you can use this to find that first standard deviation. Right? I'm going to prove 115 kilometers an hour. So let's say your speed is 115 kilometers an hour. Okay? We know that that is 1 standard deviation above the mean. Let's do the math of it. Z is equal to, I'm going 115 kilometers an hour, minus my mean, which is 105, divided by the standard deviation, which is 10. So I just substituted the values in, right? That gives me 115 minus 105 gives me 10. 10 divided by 10 gives me 1. Where was 115 kilometers an hour located? Exactly 1 standard deviation above. So what this formula does is it gives you the standard deviation. Okay, it'll give you these spots on the graphs. Now this one came out to be exactly 1. It was perfect. I know that now, what is there? How many people were less than me? Right? 50 plus the 34, 84% of the population was below me. Right? I was going at 84% speed, according to everybody else. Only 16% of the population was above me. Now, what happens if my speed, I said, what happens if I decreased my speed to 107 kilometers an hour? So let's recalculate. Okay? So this represented, 86%, I'm going at 86% faster than anybody else, faster than others. That is what that's telling me, right? Are we good there? You're giving me that look of, not sure. Does everybody understand where I got the 86? The bell curve, right? They gave me, did I add right? No, 84%. 50 plus, what is it? 50 plus 34 is 84. There we go, 84%. 84%.
You want one?
Okay? Because I was right there. So 50% to here plus the 34 gives me 84% of people are going slower than me. Or I'm 84% faster than others. But I decreased my speed down to 107. All right? So let's go 107 minus 105 divided by 10 gives me 2 divided by 10, which is what? 0.2? 0.2. Okay? Now, you will, I'm going to put a 0 on in, so 0.20. And there's a reason for that, is because we're going to look it up in the chart. Okay? So now we're going to pull our chart out. Go to the chart. You will notice that the chart has kind of a spot. You will notice that the first decimal place is running along here, and the second decimal place, the hundredths decimal place, is running across the top. So that's why I went and put a 0 on this to give me 2 decimal places. So I'm looking in the left, so this will be my left column, right? And this will be at the top of my chart. I'm looking in the chart now. Okay, so 0.20, so 0.20. Now, right there, that's my value. Are we paying attention? So now, this, as you will notice, this is from 0 out to that line. Okay? So it's 0 out to that line. So it's talking about, so 0.2 looks like this on my bell curve, right? So I'm just going to go like this and do this. So here's my mean. 0.2 is just slightly above, because I'm mean plus 0.2. That's what this line is. That's the mean plus 0.2 of a standard deviation. I'm 1/5 of the way to the next standard deviation. So that value that's in the chart is only that piece right there. And if I read it, did everybody find it? That piece right there was decimal 0.793. It is in decimal form, so you can figure out it's 7.93%. But is that meaning only 7.93% of the people are below me? No. This chart is only from the center out to that line. I need to include everything here. So if I wanted to know how many people were driving slower than me, I have to add on this piece too, which is 0.50, 50%, right? So my total would be 0.5793, or 57.93% are slower than me. Right? 84% of the people were slower than me. Now, 57.93 are slower than me. So I had to find the z-score, which could be a standard deviation, could represent one of the standard deviations if I get a whole number. But most times I'm going to use it to find that place value. All right? Does that make sense? All right? Let's see. Let's say that I went super slow. Okay, so find me. I am now down to, the roads got really nice and icy, and I am down to an average speed of 78 kilometers an hour. There's gotta be some people still driving slower than I am. I know, somebody sprayed something. Very axy in here. Okay, figure out how many people are slower than me. The road conditions have told me I can only drive 78 kilometers an hour. Where do we start, Cruz?
Well, you'd have, 78.
Okay, so Z is equal to 78 minus what?
105, or is it, yeah.
That 105 divided by 10. So 105 minus 78 is what? What are we at? 27? Negative 27. Over 10, which gives me a negative 2.7. Now, is the negative important? What does the negative tell me?
Just so you know it's below half.
Right, it's on the left-hand side. You'll always get a negative when it's on this side. Notice that this guy was 0.2. 0.2 would mean it's on the right-hand side.
0.2 above.
If it was negative 0.2, it would have been on the left-hand side. So this tells me that I am now, if I'm looking at this curve, right? If I'm looking at this curve, there's 1, there's 2, there's 3, right? I am sitting right here. Only this amount is below me. And there's 1 standard deviation right there, right? So there's my, here's -1, here's -2, here's -3. So that percentage is what I'm looking at, or my area. They always say area under the curve. I like to think of it as percentages. It doesn't make a difference, right? In decimal form, it's an area. Percentage form, it's a probability. So now, I'm going to look it up in my chart. What am I looking up in my chart? I'm looking up this. So put a 0 on the end. Sometimes it comes out to be not a 0. Look that up in the chart. So negative 2.7 would be on one side. The 0 is going to be at the top. Right? So the negative 2.7, the negative is not going to be on the chart, but the 2.7 is going to be on the chart. Then I'm going to go to the 0 because that's my second decimal place. If it was a 1, I'd go to the, or a 4, I'd go to this column, but it's a 0. So I'm going to go down until I find 2.7. Do we see that?
0.4965.
So now, 0.4965. Did everybody find that? It's kind of important. Tell me now if you can't. Everybody get that? Now you have to decipher that. Is that, what is that telling me?
49. He's above.
From where? From the center, right? Is that what I want to know? Is that how many people are below me in speed?
It'd be that plus 0.5.
Plus 0.5 or?
Because the 50, right?
Right. So this value is from here to that value. So I want to know the shaded. So what am I going to do? Right. So I'm going to take 0.5 and I'm going to subtract that off. 4965, right? And I'm going to get, what is that? 35? 0.0035. So that tells me, if I put it in a percentage, that's the area. That's the area under the curve. As a percentage, what is that as a percentage? 0.35% of people are driving slower than I am. So I'm pretty much one of the slowest ones on the road at 78 kilometers an hour. Keeping in mind that everybody else is still, the average is 105 kilometers an hour. Nobody else has slowed down for the road conditions. Only I did. Right? So I am below 1% of the population. So I am the turtle on the road. Does that make sense?
Yes, ma'am. Is that-
Okay,
is that
nope,
all?
not quite. So, what they're gonna ask you to do, so some of them are gonna come out to be nice numbers like 1, 1.25, 1.5, that sort of thing. But then they're also gonna get you, they're gonna give you something that looks like this. It says, example number 2. It says, find the area under the curve. Area under the curve. So they're asking for decimal form, right? This will be the decimal form of it. Or the Z-scores. So they've already calculated, they've used that formula, and they've calculated some Z-scores out for us, all right? And so they're asking us to find the area. Here is, so what they've done is they've already found us this value. We're just finding this. Okay? So it's a little easier, you don't have to do the calculations, right? There's no situation that's with it. So they're telling me, first one. So we have to decipher that. So 0 is less than or equal to a Z-score, which is less than or equal to 1.63. Okay, we're done talking. Done talking. So I always like to draw a little picture to tell me whether I need to be adding, subtracting, that sort of thing. So if I'm going from, so here's my little curve, there's my center. If I want 0 to 1.63, 0's here, right? Oh, no, 0 is not there. Where is 0? 0 is in the center. Right? And I want 1.63, so somewhere over here, right? I'm just kind of eyeballing it. That's the portion that I want. So 0 is representing the center. Because you would have your Z-score would be 0 at the mean. So, what am I going to do? I'm going to go to the chart. I'm going to look up 1.63. Look up 1.63, people. So 1.6 along the left side, right? 1.6 along the left side, and 0.03 above the top.
0.4484.
Exactly. So I come out with 0.04484. Now the question is that the answer, or do I have to do 0.5?
That's the end of it, it's on the right side.
Exactly. So that is the distance from here out to that line. Is that what I'm looking for?
Yep.
Done. Okay.
Would that be 44?
So if you wanted it as a percent, that could be one answer, right? If you want to do it as a percent, that's also as a percent. They're just asking you for the area, right? This is the area. Represents one full thing, right? How about this one? How about I go from Z is less than or equal to a negative 1.48. I want everything that's less than or equal to a negative 1.48. So what does the negative tell me? It's on which side, left or right?
Left.
Left. So if I'm drawing my little picture, put my mean in, right? Somewhere over here. Right? Negative 1.48 is right there. Now, what am I shading? From the center out to that line, or I want it less than that? So I would want this piece right here. What is the chart going to give me though? The chart's going to give me from here to there, right?
You do that, so you get 50%.
Exactly. So I'm going to take 0.5000 and I'm going to subtract what I get from the chart.
From a 1.48.
So negative 1.48,
0.430.
good, 0.4306. Anybody not finding that? Are good? Yeah? Okay. And I subtract that off, right? Oh, my brain's not working today. 0.0694. Okay. So obviously my picture is not drawn to scale by any means, but that's okay, all right? So there is my answer, or approximately 6.94%. How about one that looks like this? Last one of these, I think we're getting the point of them, right?
Yeah.
What about if I have a negative 1.75 to a 0.67?
8, 7.
So what do we know about this picture?
5, 6.
So I've got a negative 1.75 on one side, and I got a 0.67 on the other side. Am I gonna have to look up, how many values am I gonna have to look up?
1, 2.
2. Right, again, I like to draw my little picture, right? There's my center. Negative 1.75 is over here. These are the z-scores, right? And then 0.67 is right there. I want that region, and I want that region. Find these two values, what am I going to do with them? Add them together. Good. So yeah, the picture I just used to decide what I want it to look like, right?
6, 7.
I tend to always draw a picture.
So do you find the two numbers on the chart and then add them?
Yeah,
Oh, okay.
yeah.
So is
This
the
time
negative
sorry?
Is the negative 1.75 value negative though?
The negative just tells me that it's on the left-hand side of my picture. The Z chart, you notice, it has no negatives on it.
Yeah.
So it doesn't matter whether you're looking up negative 1.75 or positive 1.75, it's where you put it on your curve.
Gotcha.
So this right here is
6, 7.
0.4599.
And the other one is
The other one is what is it? 0.2486. Add those together. Decimals 7085.
yeah.
So that represents that because again, the chart works from here to there.
And since that's what the leftovers.
Yeah. If it was asking you who's outside of that, then you would have taken and subtracted. See, that's what I use the picture for. And the last thing that they have it is what happens if they give you an area, right? So the last one is example 3. So they're asking you to find the value in the chart. So find.
Is this the final exam?
Yeah, the value of A. And here is the first example and the second. So they tell you that the area is 0.4808, and you need to fill in the missing value. What was the Z-score that gave you, or what was the Z-score that gave you that?
Just have to search.
Yes. So you're always going to look for the one that is the closest, right? to it. So I'm gonna search through my chart and find me something. Now, it may not be exactly perfect, right? I may not find a 0.4808. Is there actually 4808?
Yeah.
And,
Okay. 0.4.
07.
2, so this is a 2 point what? 07. Now, is that going to be a positive or a negative? Positive, right? It's on that side. What happens if the 0 had been on this side and the A would have been on that side?
Negative.
Then we would have had negative, right?
How'd you find the 2.0?
We just looked through the whole chart until we found it the closest to it, right there.
what happens if you don't find it?
Then you just find the one that's closest to it. So for example, if I had a 0.0487, then that would have been the closest.
Does it matter if higher or lower?
No. Okay, and the last one here, what happens if they give me the area is equal to 0.8502 and a negative A to a positive A?
You're lying to us. You're lying. You guys are lying right now.
Yeah? I don't think so. So, I am trying to find a value. Now, what's the problem with 0.8502?
That's not on the chart.
It is not on the chart. What's the biggest possible number that's on the chart? 0.5, right? Because remember, 0.5 is on both sides. So it's asking me to find an area where something on this side is matching something on that side, and this area, total area, is 0.8502. Right. If I divide the area by 2, that will tell me this portion and this portion. Now, I can assume that they're both the same, because they're both A's, right? One is not an A and one is not a B, right? So, and they won't give you anything other than that. So we're going to take this 0.8502, and we're going to divide it in half. What do we get?
Point 4251.
251. Okay, so that is what we're going to be looking up in the chart. All right? Sorry, and what is it?
Open up the door.
1.44? So then I'm going to go back and write that in. So this is equal to 1.44. And now I'm going to rewrite it. Negative 1.44 to positive 1.44. I should do that over here too. 0 Z to 2.07. And that's finding my value of A. So this section here just has you find these, use these Z scores, find them in the chart, figure out whether you're adding it to 0.5, subtracting off 0.5, or you're adding them together. What are you subtracting? Because in the next section, we're going to look at real world, like what we did kind of yesterday. Like there is so many people that's like in these kind of questions here, right? What is, if this was a real world situation, what would that area represent, right? What population, what kind of thing like that, all right? And this shows up a lot of times with like warranty, things like that. When, what should I do? Make sure that I guarantee my product, but I don't have too many people bringing their product back to me saying it's defective, right? All right, so on your assignment, you had yesterday's, which was just writing out one standard deviation, about 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below, and then just answering the questions, right? And then this one is using the chart. Okay, so if you picked up the other one, right? So what would a Z-score for 3 standard deviations above a mean be? What would the Z-score be? Can a Z-score and a standard deviation be the same thing? Yeah. So when are they the same thing? Yeah, when they're 1, 2, and 3 above mean, right? Yeah. Yeah. So these ones, yeah, so if this is the mean, this is the mean plus a standard deviation, that's essentially, this could be also a Z-score, right? That could be equal to the Z-score. Right? There you go.